Okay, so once again, I want to welcome you to today's session. We will be looking at Module 2 of our Network Defense class, and we'll be focusing on System and Network Defense. System and Network Defense. So we will look at the first part. Then secondly, we will do a small lab activity or practical on configuring security in a wireless network. So we will look at that. So finally, I will now give you like an assignment, which you are going to work on before we meet next. Okay. All right. So we will be focusing on physical security, and we will explain how physical security measures are implemented to protect network equipments. Then we will look at network hardening services and protocols, and we will explain how to harden network services and protocol. Then we will be looking at network hardening segmentation. Here, we're going to be looking at the concept of VLANs, or rather, how segmenting your network into VLANs can secure your network. Then we will look at hardening wireless and mobile devices. Then we'll be looking at cybersecurity resilience. Okay. Now, physical security. Barricades or fencing are often the first thing that comes to mind when thinking about types of physical security. So when we talk about physical security, basically we are trying to focus on how to limit physical access into secure premises or into unauthorized locations and premises. So probably your computer rooms or your server rooms or your switch rooms or any, maybe your data centers or your things like that. How do you provide physical security to ensure that those physical devices are not accessed? So in many situations, they are the outermost layer of defense and the most visible. All physical barriers should meet specific design requirements and material specifications. So if you are a network administrator, as we look at this particular features, you'll find out whether in your own setup you are implementing this, okay? Now, the physical barriers may have some following components. Before that, let me just, okay. So the physical barriers may have the following components. It may have what we call the perimeter fence system. We'll have what they call the security gate system. We have what we call the bollard, which is a short post used to stop vehicle intrusions, okay? Then we have vehicle entry barriers, we have guard shelters, and we have fencing, right? So in most cases, those are the physical barriers. Now, a fence is a barrier that encloses secure areas and designate boundaries. You know, when designing a perimeter fencing system, the following height guidelines must apply. You know, the concept here is that you don't want either personnel, animals, or whatever device that is not authorized to cross over. So depending on the setup, there's what we call the 1 meter or 3 to 4 feet, fence. That fence will only deter casual trespassers, just 1 meter, just to that. In most cases, that particular setup indicates that you are just you are preventing people from coming in. That's all. They know that this is a barrier. Then you have what we call the 2 meters. which is the 6 to 7 feet, they are too high to climb by casual trespassers, you know. And then you have what we call the 2.5 meters, which is like the 8 feet, will offer limited delay to a determined intruder. But in any case, it's a fence that deter trespassers from crossing by. Then we have the high security areas often require a top guard, such as a barbed wire or a container wire. So the local regulations may restrict the type of fencing system an organization can use, or it's important to remember that fences require regular maintenance, okay? So moreover, vehicles should never be parked near a security fence, as this could assist in the intruder in climbing over a casual fence. So the common thinking you may have in your mind is if you go to a bank, you know, all these features are applied, especially when you go to a banking premises, the fencing area, the kind of barricade and things like that. So there are different levels of those fencing or barricades depending on the permissions that are being acquired. So fencing is one of the physical security. The second one is biometrics. Biometrics are physiological or behavioral characteristics of an individual, and there are security practices based on identifying and granting access using biometrics. You know, so biometric authentication system could include measurement of the face, you know, maybe your face like this, and then maybe fingerprint or hand geometry, iris, retina, signature, or voice. You know, all these are security measures that could be used to verify that you say you are who you are. So if you want to enter a vault or a data center or a server room or whatever, in some organizations, you use a fingerprint, you know, to authenticate you. In some organization, you use your eye retina. In some organization, you use a voice command. In some organization, you know, you use a combination of the two. In some, you just swipe your card. So whichever one, but the most important thing in biometrics is that it has to be something as part of you. All right. So if you don't have one in your switch room or your server room or your data center, do to get one. So biometric technologies can be the foundation of highly secure identification and personal verification solutions. Now, the beauty of that is that it can keep logs of who has gained access and verified if that person is the actual person that has gained access into that particular facility. So it's very important. Then biometrics can ensure confidential financial transaction and personal data privacy. A well-known example being smartphones, you know, which use fingerprint readers to unlock the device, and access apps, including online banking and payment systems. All right. So that is it. Then when selecting biometric systems, there are several important factors to consider, which include accuracy, speed or throughput rates, acceptability of users, uniqueness of the biometric organ and action, resistance to counterfeiting, then reliability, and then data storage requirements, enrollment time, intrusiveness of the scan. The most important of these factors is accuracy, which expressed in error types and rates. Okay, so remember, we are looking at physical security, all the physical security that may be required when you are providing security to your data center or server room, something like that. So we are looking at biometrics. We have looked at fence. We are looking at biometrics. Okay. Then the next one is surveillance. Many physical access control including deterrent and detection system, ultimately rely on people to intervene and stop the actual attack on intrusion. Okay? Intervene and stop the actual attack on intrusion. So surveillance is when you use cameras, CCTV cameras, could be IP cameras or analog or whichever one, but CCTV cameras are very good surveillance. So video and electronic surveillance can supplement or in some cases replace security guards. So the benefits of this video and electronic surveillance include ability to monitor areas when no other persons are present. The concept here is that security guards tend to get tired or they may not be able to go around all the places at the same time or 24/7. So these security cameras are there fixated. Some of them have what we call motion detectors. So if they observe any motion, they begin to record and then they tilt or face that particular area that there's motion. All right. So in a high secure environment, video and electronic surveillance should be placed at all extreme entrances, exits, loading bays, staircase, and refuse collection areas. So if you are installing this surveillance in your organization, you target these areas, especially the entrance and exits, those doors, the main entrance, the main exit, staircase. Then you can now look at other locations within, guards and escorts. Security guards are a great solution to access control. Requiring an instantaneous, just a minute, come in. Okay, sorry about that. All right, so disadvantages of guards and escorts include cost and the inability to monitor and record high volumes of traffic and the risk of human error. So in highly secure information system facilities, guards control access to the organization's sensitive areas. Okay, so the benefit of using guards here is that they can adapt more than automated system. Guards can learn and establish and distinguish many different conditions and situations and make decisions on the spot. Okay, so that's very, very important. So it's still part of surveillance. Now, still part of surveillance, we have what we call the RFID and wireless surveillance. RFID means radio frequency identifier or identification. Okay, so managing and locating important information system assets is a key challenge for most organizations. So growth in the number of mobile and IoT devices have made this job even more difficult. So the use of radio frequency identification assets tag can be of great value to the security staff. Now, let me use this for instance. Maybe you have an ID card, you have an ID card, and so the ID card has this RFID chips on it. Now, what it does is that anytime you are trying to maybe gain entrance into a particular location, you swipe that RFID and then it takes note of it, So that particular card has a chip, and that chip is what we are talking about. So in most cases, it helps to keep track of it. Another one is if you go to big malls or supermarket, you buy some stuff, maybe you buy a remote or you buy a pen or whatever it is that you buy, you go to the counter and then they use like a scanner. It use as a scanner to deactivate the code or the RFID there. Okay, so when they use the scanner to deactivate, by the time you are going, number one, it records on the system that this device, this item has been purchased. And then two, it doesn't trigger an alarm. But if you don't go for them to deactivate that code, by the time you are exiting, probably it's assumed that you have stolen it. There will be an alarm because the wireless device have been configured that any code that has not been deactivated, the alarm should blow. So that's why sometimes they are used in malls or supermarkets to give control or to control who carries what, things like that. So an organization can replace RFID readers in the door frames to secure areas so that they are not visible to individuals. So the benefit of RFID asset tags is that they can track any asset that physically leaves a secure area. That's just what I said. So the new RFID asset tags systems can read multiple tags simultaneously. RFID systems do not require line of sight to scan tags. Okay? So another advantage to RFID is that the ability to read tags that are not visible. So unlike barcodes and human readable tags, that can be physically located and openly displayed to read, RFID tags do not need to be visible to scan. So most of the ones that I'm talking about is the one that you can scan, but the RFID is in the chip, it's in the card, so you may not be able to see per se. Okay. So we have looked at the physical. Now let's look at network hardening. And under that, we'll now, first of all, look at services and protocols. Now, in this section, we're looking at network services and protocols and how they can be used to harden your network, okay? So the first one is network and routing services. When you say routing services, what are we talking about? Generally speaking, you have a network, and in your network, you have devices. Part of the device is a router. What is a router? A router is a device that determines the best path to forward your packet. Okay, so it does path determination and packet forwarding. So there are instances that path forwarding or path determination or packet forwarding can be tampered with. So how can you use that as security? Cyber criminals use vulnerable network services to attack a device or to use it as part of an attack. Okay, to check for insecure network services, use a port scanner to detect open ports on a device. Now, when we talk about open ports, what it means is that in network communication, that's what we call the OSI model layer. It's like just a communication reference model that explains what happens. And in that reference model, is saying that there are 7 layers. The first layer is physical layer. They call it layer 1. Then the layer 2 is the data link layer. The layer 3 is the network layer. Layer 4 is the transport layer. Layer 5 is the presentation. Layer 6 session, and layer 7 is the application. Those layers they explain the concept of how devices communicate from source to destination. Now, the concept of port to be open or closed is being done at the layer 4, which is the transport layer. Layer 4 in the transport layer talks about whenever a system wants to talk to another system, probably a client wants to talk to a server, there is a port. The port is like a window, is a number that identifies the client and identify the service on the server. So for instance, if my system wants to browse the internet, my system will browse the internet on port 80. Port 80 is the port that has been designated for web traffic services, as the server. So the destination port will be now port 80, but the source port will be a randomly generated number. So that particular port that is used for the server, port 80, is being used. You can have another port, maybe for file transfer protocol, maybe called port 21. You can have another port, maybe for DNS, maybe C53. You can have another port, different ports for all the services that you want to use. And you have them configured on your server or on your network. All the ports you want to use, they have all the services you want to use, they have their own ports. Now, if there is a service that you have configured on your network and you are not using it, the idea is to close that port. There is a ways you do about that. We'll talk about that much later. But if you leave that port open and you are not using that particular service, that is where your vulnerability comes in. So it says to check for insecure network services, use a port scanner to detect open port on a device. So the open port is the port of a particular service you have configured on your network and you are not using. Okay? So a port scanner sends a message to each port and waits for a response, which indicates how the port is used and whether it is open or not. Cyber criminals use port scanners for these same reasons. So securing network services ensures that only necessary ports are exposed and are visible. All right. So it's like the port is like a window in your house. It's like a window in your house. So if you open a window, in your house, you are allowing traffic to come in. Somebody can come into your house through window. But if you close the window, nobody can come in. So you can say, I am opening the window because I want breeze to come in. I want cats to come in. I want whatever it is you want to come into the house. But as soon as they are done, you close it. Okay? That's just the point we are making. Another service that needs attention is what we call the DHCP service, the Dynamic Host Control Protocol. What is this particular service? Every system on the network needs an identification. An ID is like what identifies the device uniquely on the network, and mostly is called an IP address. An IP address is like the internet protocol. Now, that IP address is like matric number for students who are admitted. So if you are admitted in an institution, you are given a matric number. That matric number is supposed to be unique. No one is supposed to have no two people are supposed to have the same matric number. Okay? So that matric number is unique. It's the same as saying your driver license number. You cannot have two drivers having the same license number. Or let's say your BVN number. All right? You cannot have two people having the same BVN number. No. Or we could say your NIN number, National Identification Number, or your Social Security number. All those numbers are unique, which means you don't expect two devices to have the same number on the same network. Now, it's the same thing with digital devices. All end devices or intermediary devices, all devices on the network that needs to communicate need to have this IP address. The question is, how do they get this IP address? There are two ways they get this IP address. One, they get it manually. Manually means that you as the network administrator will be the one to assign this IP address on the devices. Okay. Another way to do that is dynamically or automatically. What means is that you will configure your router to give out these IP addresses. You only just tell the router, I have 2,000 IP addresses, and I want you to give out these IP addresses automatically as the devices connect to the network. As any device connect to the network, give it out these IP addresses from this particular pool. That is the job of the DHCP server. So it is a server that assigns IP addresses to systems. So in effect, the device gets the permission slip from DHCP server to use the network. Attackers can target DHCP server to deny access to devices on the network, but security measures like DHCP snooping prevents rogue DHCP server from providing IP addresses to clients by validating messages from sources that are not trusted. What are we saying here? It is possible that somebody can connect to your network and decide to set up a particular DHCP server. You already have a DHCP server. In other words, you have a machine that is automatically giving out IP addresses to these devices. And part of the IP address information that it gives out, it gives them their unique IP address. It also gives them what they call the default gateway. The default gateway is to say, okay, if you are going out of this local network or you're going to the internet, follow this particular door. All right, follow this door, or this is the default gateway. And then it also gives them information about the DNS. You know, DNS is a domain name resolver. You know, it converts the IP address to the domain name, for instance. So instead of calling the MAC number of the person, you just call the name of the person, you know, something like that. Now, if somebody or a threat actor connects to your network and sets up a rogue DHCP, when we say a rogue DHCP, means that an unauthorized DHCP server. So which means your system devices are going to be getting their IP addresses from this guy. They will also be getting all this other information from this rogue device, which means it's going to cause problem, okay? So one way to prevent it is use what we call DHCP snooping, right? Because that's what it does. It helps to prevent any rogue device. So how do you know a rogue DHCP? You must give an authentication to the main DHCP. So a security checklist for DHCP physically secure, one is to physically secure the DHCP server, all right, to ensure nobody have access. Another one is apply any software patches, which means you need to be updating your DHCP. Then number 3, you locate the DHCP server behind the firewall. Now, when they say behind the firewall, remember what we looked at, this is your cloud. This is your ISP. Now, your ISP is connecting to you through your edge router. Are we together? Your edge router then connects to your firewall. All right, it now connects to your firewall. Then you now connect to your local router, your local network. Now, when you say your DHCP should be behind a firewall, what we are saying is that when traffic is coming this way, your DHCP should be located, this is your firewall. So it should be located anywhere between here and here. Okay? Anywhere between here and here, but not here. Not anywhere here. Are we together? So you should be able to keep it behind so that because its job is to serve your local area network. Okay. So monitor DHCP activities by reviewing your DHCP logs. Yesterday, we talked about the importance of logs. Okay, it gives you an idea of what is happening. So the logs in DHCP server, what it does is that for every IP address it gives out, it generates a log. Maintain a strong antivirus solution on the device, and then uninstall any unsafe or unused services and applications, and then closed unused port. All right, so DHCP is a service. All right, remember we're looking at network services and routing protocols. Another service is the DNS. DNS, like we said, is domain name system. What it does is that it translates your URL or your website or your domain name to the corresponding IP address. For instance, if I have a domain as cisco.com, for instance, cisco.com. This particular domain name has an IP address behind it. So let's find out. How do I find out? Let me share my screen. Come. Okay, so let me share this so that okay, so now this, I've just loaded my command prompt. I want to believe that you should be able to see it. Now, if I want to find out the IP address that is behind a domain name, it's just for me to ping it. I can just ping cisco.com, for instance. You will see that my DNS will do the resolution. What will it do as a resolution? You see, this is what I typed. This is the domain name here, cisco.com. And what will the DNS do? It will convert, it will take this domain name and look for the IP address, which is the unique ID. And look at it, it has found it. And you see, this is the IP address. And then you see, it will now check connectivity. I can do it for Google. Say google.com, for instance. Can you see? It will give me the IP address for Google. Now, what it means is that instead of typing google.com on my browser, I can easily pick this particular IP address and put on my browser, and it will be able to bring for me Google. Let's give it a try. So let me copy this. Hope it has copied. So let me launch my browser. Okay, you guys cannot see it. Let me share it. Okay. All right, this is my browser. All right. Now I can just put the IP address here. All right. I've just put the IP address and see what it's bringing for me. It will bring for me Google, because that is the IP address. Or I can now see who is, if I put this IP address, it should be able to tell me that the IP address belongs to Google. Can you see? Can you see it here? Just by asking who is, it will tell me the IP address belongs to who? It belongs to Google, right? So how is the system able to do that? It uses what we call DNS, okay? DNS. So DNS security extension uses digital signatures to strengthen authentication and protect against threat. Because if your DNS is working well, you don't have a problem. But if a threat actor decides to hack into your DNS, when you type a domain name, Instead of resolving to the correct IP address, it will resolve to the threat actor's IP address. So it will redirect you to somewhere else. And that's a problem. We don't want that to happen. All right. So the security checklist for DNS include you keep DNS software up to date. Up to date. Make sure your DNS is up to date. 2, prevent version string. Okay. Then from revealing information. Separate internal and external DNS servers. Remember that I told you that you can have maybe this is your internet, and then this is your edge router, this is your firewall, then this is your internal network. Now, in your design, a simple design could say, because this is your firewall, you will have what they call a DMZ here, all right? Or in some organizations, they may decide to have their DMZ here, DMZ, okay? Demilitarized zone. Now, what is this DMZ? It's just a place where you will have maybe some of your devices that you will want them to be public. So you could have it here, or you could have it here. So if your DMZ, where your DMZ sits is where your DNS is going to sit. All right. So when they say separate your DNS, your local from your public, this will be like your local DNS. Then your public DNS may be in the cloud. All right. But if you don't want to have your public DNS in the cloud, then your public DNS may be here. Then your local DNS may be here. Right? So restrict allowance transaction by client IP addresses, and then use transaction signatures to authenticate transactions, disable or restrict zone transfers and dynamic updates such as much as possible, and then enable login and analyze logs, and then use domain name system security extensions. You know, these are some ways that you can secure your DNS. Another service, another network service that needs securing is what we call the ICMP. You know, when we run a ping, it uses ICMP protocol. You know, the ICMP stands for Internet Control Messaging Protocol. So network devices use ICMP to send error message that a requested service is not available, okay? Or the host could not be reached, or the host is rich. For instance, like what we did here. So you see, it is the ICMP that gave us these results. You see, from this ping result, is the ICMP, because you use ping, you get ICMP. Another ICMP tool you can use is TraceArt. I can say TraceArt, which website should, let's say CNN.com, for instance. What I'm saying is that I want it to trace CNN.com from my system. So it will tell me the steps or the routers that the system is going to follow in order to get to CNN. And the guy that is doing this is the ICMP protocol. So whether you use it for ping or you use it for TraceArt and things like that, is the ICMP. So it helps to check the reachability, you know, of a network. So it's either it tells you it's reachable, or it's timing out, or it's unreachable, or whatever. So you see, what we are seeing here are different networks or different routers that the traffic on my system passes through in order to get to CNN. All right. These are all of them. So it's still moving. That's not yet gotten to CNN. It's still traveling. So it's the ICMP protocol that does that. Now, why then do we need to secure the ICMP protocol? So once it gets to CNN, you're going to see it's going to tell you it's complete. Okay. All right, still moving. Still moving. Still moving. Okay. Okay. CNN is quite far. Number of routers that the drive here is now complete. It has to go through 18 routers, 18 routes, right? So that's the ICMP. So the ping command is a network utility that uses ICMP to test the reachability of a host or a network. So ping sends ICMP message to the host and waits for a reply. Cyber criminals can alter the use of ICMP to run reconnaissance or even denial of service attack and even covert channel attacks. So many network filters ICMP requests to prevent such attack. Okay, so for instance, I can say I want to prevent ICMP to my web server, all right, or to my router, to my firewall, which means if somebody from outside tries to ping my own server, it will say not available, even though it is available. So anybody, like now, we just ping Google or we ping CNN and we got it is reachable, all right? It is reachable. So if I know it's reachable, then I'll begin to make an attempt to reach out to it. So some in the ICMP, some organizations, you disable this particular feature. Another one is routing information protocol. It's like it's a service that helps the router in taking its decision. Remember, we say the router does path determination. When a traffic, for instance, this is a router, and this router has leg to go to this. It can go here, it can go here. The router has different paths. Now, when a traffic comes into this router, it is the job of the router to determine the shortest, safest, most reliable path in order to forward the packet. That's the job of the router. Okay, so it makes this decision based on what we call the routing table. The routing table is just a database where the router keeps records of all these routes. Okay, so if a traffic comes, it checks on the traffic header. Where is the destination of this traffic? Based on the destination that is there, it will say, okay, forward traffic this way. It will look at, okay, based on available bandwidth, maybe the congestion on the network, maybe consider some other metrics, then it will decide the path. Okay, so RIP is one of the dynamic routing protocols that helps the router in making this particular decision. And one of the things that the RIP uses to make this decision is the hop count. When we say hop count, for instance, you see this, we are saying this guy, the traffic goes through 18 hops in order to get to the destination. It goes through 18 hops. So the hop count is to say how many hops does my traffic need to pass through in order to get to the destination. And then the more the hops, the more unlikely the router will take that path. But the lesser the hop, the more likely. So RIP calculates the best route based on hop count. So cyber criminals can also target routers and the RIP protocol. Such attacks on the routing services can affect performance and availability. Some attacks can even result in traffic redirection. So some use secure services with authentication and implement system caching and updates to protect routing services. Okay. We have another protocol that you configure on your network. It's called the NTP, Network Time Protocol. Now, the NTP protocol or the network time protocol basically helps to synchronize the clock of your devices. You have servers, you have routers, you have switches, you have access points, you have different devices on your network. And remember, we talked about the logging, the system log where you keep records of what happens and things like that. Now, the NTP helps to provide accurate timing across your network. So if you are doing audit or investigation and you want to check what happened by so time, you would be rest assured that you have the correct time. But if you don't, if somebody alters the NTP or you don't use NTP, then you may have this server is bearing this maybe 4 o'clock. Maybe the next server is using 6 o'clock. Maybe the access point is showing 7 o'clock. Another switch is showing 10 o'clock. Different devices are showing different clocking timing, and that is wrong. So having the correct time within network is very, very, very important, especially when you have correct timestamps, accurately tracks network events such as security violations. And also when you want to use Internet of Things, you want to automate your network or automate your house, your home, and things like that. It works based on the synchronization of time. So NTP allows network devices to synchronize their time settings with an NTP server. So cyber criminals can attack the time server to disrupt the secure communication that depends on digital certificates and to hide attack information. So you can use NTP authentication to verify that the server can be trusted. Okay. So we have been talking about network protocols and network services so far. Now, and we have seen how to harden your network based on that. Now, how about Telnet, SSH, and SCP? What are these protocols? These protocols are designed to help you remotely enter into your device or to help you connect to your device securely remotely from another location. So as it is now, I am at home. Probably I want to log into the server or the network in my office. I should be able to log into the network remotely. All right. So I may not need to be physically present to connect my cable to it. So that's what Telnet, SSH, and SCP does. Now, each one of them have their advantages and disadvantages. For instance, the SSH is called a secure shell. It's a protocol that provides secure remote connection. And when we say secure, it's because it is encrypted. Okay, so it provides secure remote connection to a device. Telnet, which is an older version, all right, also gives you that feature, but it is not secure because it's not encrypted. It is in plain text. It does that in plain text. All right. So when you're logging in with your username and password, anybody that intercepts that particular traffic can interpret, can see in plain text username and password. Like what we used Wireshark the other day. We ran the Wireshark and we were able to see details. So if you use Telnet, you will even see the username and the password. Okay. So SCP is what they call secure copy. It's used in transfer of files between two remote systems. Okay. So, okay, like what I said earlier on, using Wireshark, you can be able to interpret that. You can see the plain text, usernames, and passwords. All right. So another protocol that we have that we need to work on is what we call the SNMP, Simple Network Management Protocol. What is this protocol? The SNMP is just a service that you configure on your network, and it helps you to manage other devices. For instance, you have access points in your network. You have switches in your network. You have your routers in your network. You have your cameras in your network. You have some other devices. And you want to have a single device where you will just log in and then check, is this device up? Yes, it's up. Is it down? No, it's not down. You want to check your servers. What is the temperature of your server? What is the hard disk space? Is it full or not? You don't need to physically go into the device to be checking. So you can remotely do that. So one of the protocol that helps communicate between the device and the machine that does this monitoring for you is the SNMP. What does it do? It collects statistics, from the IP address that you want to monitor. All right, so SNMP version 3 is the current standard. It uses cryptography to prevent eavesdropping and ensure that data hasn't been tampered while on transit. So because SNMP communicates between the device and the server that does the monitoring, anybody that is dropping or that is listening to that particular traffic can be able to capture the information that is being exchanged. Okay, that's the SNMP. Another protocol is the HTTP, Hypertext Transfer Protocol. This HTTP is just a protocol we use to browse. Your browser, your Opera Mini, your Firefox, your Internet Explorer, your browser that you use to browse, it uses HTTP. All right. And most web HTTP protocols run on port 80, like the port that I told you about. So they run on port 80. So, but they contain limited built-in security and is open to traffic monitoring when transmitting content. All right. So leaving users' computer is actually open to attack. So what do? You use what we call this SSL. Now, in the SSL, what we are saying is that when you browse a website, you will see instead of HTTP, you should see HTTPS. HTTP, and then you will see an S. Neat. Now, in some scenarios or in some cases, you will even see a padlock. Okay, you will see something like a padlock, over there, which means that it's encrypted. Okay, so you use an SSL, which is secure socket layer, to manage the encryption by using the SSL handshake at the beginning of the session to provide confidentiality and prevent eavesdropping and tampering. Okay, so that's why sometimes you visit some website, it says this site is not secure. It means that they are not encrypting it. Then you also use what they call TLS, Transport Layer Security, is an updated, kind of more secure replacement of SSL. All right, like more secure of SSL. All right, so SSL TLS encrypts communication between the client and the web server. Where it's used, the user will use HTTPS in the user field of the browser instead of HTTP. Then we have the file transfer protocol, where you move files from one computer to the other. One computer to the other. Now, in the process of transferring these files over the network, there are instances that these files are transferred in plain text. Okay, especially when you would have to log in order to ensure this transfer. So that's why they have what they call HTTP FTPS. The FTPS is more secure because it adds the TLS, all right, and the SSL, all right, to prevent eavesdropping. So that's for transfer. How about for mail? Email uses what we call the POP, which is the Post Office Protocol. And then you use the IMAP, which is the Internet Message Access Protocol. and multipurpose internet mail extensions, MIMI, all right, to attach non-text data such as an image or video to an email. So there are different ports that all these things work. So to secure POP, it uses 110 port. For IMAP, 143. And that way it helps to secure your communication. All right. How about network hardening segmentation? Right. So a VLAN is just a virtual local area network. When we say a virtual local area network, it's a local area network actually, but it's segmented. Segmented means that you have partitioned it. You have partitioned for each segment, each group. Okay, so this segment cannot talk to the next segment on their own. This segment cannot talk to another one on their own. They actually require maybe a router or a layer 3 switch that will help them communicate with each other. So for instance, in an industry, you could say accounting department or accounting is different from marketing, different from production, different from sales. So the computers that talk within administration can talk with each other. The computers that talk within accounting can talk with each other, but they cannot talk together with the ones in sales and marketing and things like that. Okay, so the concept of this network segmentation is just to group devices for ease of management and security, so that in case, even if one segment is affected by a particular malware, it does not spread out too quickly to the others. So VLANs provide a way to group devices within a local area network and on individual switches. VLANs are not the same as LAN. Virtual LANs are based on logical connections, while LANs are based on physical connections. Individual ports on a switch can be assigned to a specific VLAN. So I understand some of you may not be very good in networking, but you are taking this cybersecurity. It's always good to have network background. All right. So after this training, we'll set up another opportunity where we will organize a training on networking. All right. So basic networking, especially the aspect of IP address management, basic network device configuration, setting up of LAN, some of those LAN concepts, I say LAN networking concepts. We'll have a session where we will talk about that. So maybe much later you can be part of it. So the network is segmented. VLANs allow an administrator to segment a network based on factors such as the function or project team or even the application. In an institution, you could say based on faculties, departments, and directorates. You can segment your networks based on that. All right. Or you can even segment it based on functions, or you could say staff, students, and guests. You understand? You could do that segmentation. So devices within a LAN acts as if they are on their own independent network. So you have partitioned it, you have grouped them, and they function within their own right. So a VLAN can separate groups of devices that host sensitive data, right? So trunks allow individual VLANs. So this is what I mean. For instance, you have a switch here. And then you have another switch here. All right. Now, this switch has port 1, 2, 3, and 4. This one has port 1, 2, 3, and 4. And you are saying you want to create probably VLAN for staff and students. And so you have created, maybe you have access points, APs that are connected, and you want them to talk to each other. Then you can say, I will put AP1 here. And then another AP here. And the APs that are here are going to be for staff. Are we together? This is in building A. This is in building B. Building A could be, let's say, Faculty of Computing. Building B could be maybe Faculty of Engineering or so. Now, port 1 and 2 are connecting to APs for staff. Then 3 and 4, there are APs that are connected for students. Now, they are within the same building, mind you. All right. So those here cannot talk to those here because you have separated them. You have separated them virtually. This is a different VLAN. This is a different VLAN. But you want to extend this configuration to Faculty of Engineering. Then you make a particular cable connection between these two switches. Now, this cable connection between these two switches, and you have the same VLANs here for staff, same for students, which means that every information, this cable here should carry information about the VLANs of staff and students from the first device to the second device. So the cable that does that is called a trunk. So a trunk cable carries all the VLAN information. Even if there are 50 VLANs in a switch, it carries all the VLAN information. It carries it from one switch to the other switch. The way it gets to that particular switch, everybody is on its own, right? So that's why we say trunk allows individual VLANs on the switch to move. Okay, so it's important. Now, if somebody connects to your network and he decides to connect to a trunk port, that is why physical access to your network should be prohibited for people who are not supposed to. People who are not supposed to have access to your network should not be allowed close to your network. So if somebody comes and connects to your trunk port, he can be able to see all the traffic that is moving from all the VLANs from one port to the other, right? And that is not good. Then we have the DMZ, the demilitarized zone. A demilitarized zone is a small network between a trusted private network and the internet. So access to untrusted network. Web servers and mail servers are usually placed within the DMZ to allow users access the untrusted network, such as the internet, without compromising the internal network. Now, what are we talking about here? We're talking about the fact that you have a network. And in your network, for instance, you see in this diagram, this is the internet. So the internet we refer as untrusted. Why do we refer it as untrusted? Because we do not know the traffic that is going to come. We don't know everybody there. So we just say it's untrusted. Then we have our local area network, our LAN, which is trusted. So we know that one, so it's trusted. Now, the DMZ is in between. So like the analogy I used earlier on, where you have your ISP, and then you have your router, your edge router, then you have your firewall, then you have your LAN. All right. So now you see from here is untrusted. All right. From your edge router, this way is untrusted. From here is trusted. So if there's any way that you will have your DMZ, you can have it here. You have your DMZ here. All right. So that is what you can have. Or you can have your DMZ here. Depending on what you want, but probably most likely here. That's what we are saying here. So the DMZ is where you keep all your servers, all right? The kind of servers that that you will want to have access to the internet. Now, in DMZs, or DMZs, there's what we call zones of risk. Most networks have 2 to 4 zones of risk: the trusted private LAN, the DMZ, the internet, and the extranet. Now, within the LAN zone, the risk level is low and the trust level is high because they are your users, you know them. Within the extranet zone, the risk level is medium and the trust level is medium. Within the DMZ, the risk level is medium high, the trust level is medium low. Okay. Within the internet zone, the risk level is high and the trust level is low. Then we have zero trust model. Firewalls manage east-west traffic that goes between servers within the organization's data center. That's what we call east-west. Then the north-south traffic, data moving into and out of your organization's network. So when you say north-south, you are talking about from internet to your organization, and then from your organization to the internet. That's north-south. When you say east-west, you are talking about intranet activities. So we have internet activities and then intranet. So to protect its network, an organization can implement a zero trust model, automatically trusting users and endpoints within the organization can put many networks at risk, as trusted users can move throughout the network to access data. Zero trust networking constantly monitors all users on the network, regardless of their status or their role. Then we're almost done. Hardening wireless and mobile devices. Now, when we say wireless devices, we are basically talking about Wi-Fi or point-to-point or point-to-multipoint. So wired equivalent privacy was the first security protocol used for wireless networks. This was replaced by Wi-Fi protected access, WPA, which improved the security of wireless connections. WPA configuration. Wi-Fi protected access, which is WPA, was the computer industry's response to the weakness of wireless encryption or equivalent privacy standards. WPA and pre-shared key is the most common WPA configuration. The keys used by WPA are 256 bits, a significant increase over 64-bit and 128-bit keys is used. What is all this English talking about? By trying to say that when you are connecting wirelessly, usually you used to put password. Is that not so? You want to connect to hotspot or connect to something, you say enter password. Now, when you enter the password, what is the encryption level of that password? That password that you enter, can somebody sniff it and easily decode it? That's just what we are saying. It says initially, the encryption was not good. That's why they talked about the WPA, all right, or the WEP. They are not really strong. They are not good. So the ones that are much better now is the WPA pre-shared key. And that one they are saying is better because they have increased the encryption length to about 64 bits to 128 bits. So that for you to be able to decrypt it, it will take some time. But it has some features. The WPA provides message integrity check, which could detect if an attacker had captured an altered data passed between the wireless access point and the wireless client. The access point is the AP, all right? So you have the AP that is giving wireless, then you have the PC. You have the PC that is connecting to it, right? So the Temporal Key Integrity Protocol, TKIP, is another protocol that does the encryption, all right? The Temporal Key Integrity Protocol standard helps to better handle, protect, and change encryption keys, all right? But that has not been doing very, very, very well. So they introduced another one, Advanced Encryption Standard, AES. It supersedes the TKIP for even better key management and encryption protocol. So what we are saying is that if you're configuring your access point, the protocol the encryption you should use for your password is AES, not TKIP. So the Wi-Fi protected access standard was released in 2002. This introduced the mandatory use of AES algorithms and replaced TKIP with the Contier cipher mode block. The Wi-Fi protected access added more features to the WPA2, such as maintaining strong cryptographic algorithms and improving key exchange. So the Wi-Fi protected setup, WPS, can be used to set up a secure wireless home network. A PIN code is used to connect devices to the wireless network. However, WPS poses a major security vulnerability as the user PIN can be discovered through a brute force attack. Due to this, WPS should not be used and should be disabled altogether. Finally, let's look at a few security resilience. What is this security resilience? The term high availability describes systems designed to avoid downtime as much as possible. So resilience here is just what we can do to ensure our system does not go down. The services that you are running on your network does not go down. You know, that's just what this resilience is talking about. So the continuous availability of information system is imperative, not only to organizations, but to modern life. as we are all doing and relying on computer and information systems more than ever before. So high availability systems typically are based on 3 design principles: eliminating single points of failure, providing for reliable crossover, and detecting failures as they occur. So what we are saying is that when you are looking at cybersecurity resilience, even when you are attacked, how you can still maintain activeness. Number 1 is high availability. Okay. Number 2 is to look at the concept of the 5 nines. Now, every organization wants to be able to operate uninterrupted, even under extreme conditions such as during an attack. You know, we've had stories about banks being visited. Now, but during the period, has it affected services? It's up to you to decide. One of the most popular high availability goals is often called the 5 nines. It gets its name from this. This is the 5 nines. 99.999%. That's how you get the 5 nines. Your availability should be 99.999%. You can never have 100%. All right, so but you can have 5 nines. So in practice, this means that your downtime is less than 5.26 minutes per year. You should not say within a whole year, you should have a downtime of more than 5.26 minutes. So these are the few common steps that you can take to ensure that you have your 5 nines. All right. Number 1 is standardized system. Now, what does this mean? System standardization provides for systems that use, same components. As a result, part inventors are easier to maintain, and it's possible, to swap them and things like that in case of emergency. All right, maybe you're using this particular type of router or this particular type of servers, and you should have some extra hard drives in case anything happens. Then you have what they call clustering. Clustering is where you have a group of devices, maybe servers or switches. You put them together and you configure them to work as one. All right. So even though physically they may appear to look multiple, but logically it is just one device. So in case one fails, the other one is still running. All right. So that's the concept. So if you standardize your system, it will help you. Number 2, if you do clustering, it will help you. Number 3 is shared component system. Systems are built so that they can compete system and can stand in more, things like that. Then avoid single point of failure. Single point of failure are weak links in the chain that can cause disruption in the organization, which means if your router is target and your router goes down, your network goes down. No, you should have redundancy. Redundancy means you should always have 2 or backup. In case this happens, the other one is still running. Okay, so that's what we are talking about, redundancy. Then you need to have what we call RAID, especially for your servers. The RAID takes data that is normally stored on a single disk and spread it among several disks, except RAID 0. Now, what it means is that if you have a server that has 4 hard drives, okay, you can configure the server to say, okay, I want to just use 2 of these hard drives, but I want you to replicate exactly or mirror whatever is in these 2 hard drives, replicate them on the other 2. That is the concept of RAID. You now configure for the backup. So in case this one fails, you can just switch over to the other ones, okay? Then spanning tree. Spanning tree is a protocol that is used basically for switches. Where you have multiple switches, there's a tendency of having a loop. For instance, now if I have, let's say I have, this is one switch, I have two switch, I have three switch. Then I have a cable coming here. I have a cable coming here. And then I have a cable coming here. Switches by default are broadcast devices. So any traffic that comes to a switch, it is broadcast to go out through all the ports except the incoming port. So if a particular traffic comes in here, this guy broadcasts the traffic to all the ports except the incoming port. So it means the traffic will go out here. Once it goes out here, it comes to this switch, and this switch rebroadcasts, and then it goes out here. Once it comes to this switch broadcast comes here. The same thing, so you see it becomes a loop. All right, so one way is use spanning tree to block it. So spanning tree will look at and then maybe block one particular port to avoid, to stop the loop from occurring. Okay, so that's the setup. All right, so you have traffic coming in here, and then it will go out through this guy, and this guy sends it to this guy, and then this guy on a normal day will send it back here, but spanning tree will just block it, right? So we have redundancy. We've talked about redundancy. This is redundancy. So basically, backups. Backups are very, 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 very important. An organization can lose data if cyber criminals steal it, if equipment fails, or if a disaster or other errors occurs. So it's important to back up your data regularly. So backup stores a copy of the information from the computer to the backup media, right? To the backup media. So, all right, I just want us to look at so this is it. Managing threats on physical facilities. Managing threats on physical facilities. So organizations can implement various measures to manage its threats to the physical facilities. For example, access control and closed circuit TVs, that is CCTVs. All right, policies and procedures, building security testing, including using both digital and physical means to covertly gain access, and then badge encryption for entry access, disaster recovery planning, business continuity planning, regular security awareness training, and things like that. So if your organization has not made that, then you need to do something about that. All right, so that's the end of this. So we'll quickly, what's the time? If we can quickly look at the packet tracer. Okay. Okay, all right. So let's quickly look at the packet tracer. No, time has gone. Okay. Now, in the packet tracer, we'll be looking at there are other packet tracer activities, which I believe by now I've sent you guys the link how you can access and download the materials. So I'll tell you what you will do by the end of the class. So, but for this activity, we have 4 objectives. 1, we will configure basic security settings for a wireless router. Then we will configure wireless router network security. Then we will configure wireless client network security. Then we'll verify connectivity. But if you can do 1, 2, 3, then the other ones, it's not much of a problem. Okay, so what is the scenario? It says in this packet tracer activity, you will configure wireless security on a wireless router. During installation of the router, it was partially configured, but some has security issues and need to be addressed. You will also need to harden the router to help mitigate potential attacks. After the security configuration is complete, you will verify connectivity and security settings. Most tasks in these activities are graded, so check your results as the time goes to view your correctness or things like that. So let's go to part one. Part one, step one, we're supposed to change default router password. Like I said in our previous class, it's always important if you buy a device, don't use the default settings. Always change it. So let's begin by changing. All right, so click home, then click home PC, desktop tab, go to browser. So where is home? This is home. Okay, then they say we should go to home office PC. Where's home office PC? This one is family PC, right? Okay, this one is home laptop, right? This one is what now? Okay, there's another one here. This is home laptop. Can you see the description that comes out from your own end? Can you guys see it? Can you see the description when I
Yeah, we can see the description. So.
all right, all right. So this one is home laptop. And then I think which one is this one? Aha, this is home office PC. All right, so it says we should click the home office PC, go to desktop tab and open the browser. So I will click, let me ensure that I am sharing properly. Yes. Okay. All right. So this is it here. And then they say we should go to desktop. We're in desktop, and they say we should go to browser. Okay. So this is web browser. It loads. Now, B says what? Connect to the home wireless router at this. This is the IP address. This is the IP address of the home router. So from what we are doing is that from the PC here, this is the office PC, we want to connect to the home router. Enter the home router. So I'll enter the IP address here, 192.168.0.1. So usually there is a default username and password, and that's what C is telling us. Enter admin for both username and password. In fact, this IP address is the default IP address for most of the routers. So you are supposed to change probably when you buy your the username and passwords are also default admin. All right. And then password admin. Then we enter. So this is the router. Okay. Now, this is click the administration tab and then enter this for both password fields. So let me just copy it. Copy it. Yeah. We should go to administration tab. Where is it? Click the administration tab. Where's the administration tab? So this. Okay, so we'll go like this. Oh, see the administration tab here. Okay. So the administration tab, and then they say we should enter this password. Cisco docs. So copy, delete, and paste. Okay. Copy again. See if I can paste. Good. So we should re-enter the password again. So you see, we are changing the password from the default admin. We're changing it. So now easy, scroll down to the bottom and click save. So save settings. All right, so it's asking for username, password. Enter the password that we have done now. Okay, successful. So you see settings are successful. So we have successfully changed the password. Okay, now step 2. So we see we have done step 1, simple. Step 2 says disable remote management. Remote management is that you can log in remotely to be able to manage it. So you go to administration tab and click disable next to remote management. So go to administration, right? Then can you see remote? This is remote access here. And then see is enabled. So just click disabled here. Right? So click disable remote management. And then scroll down and click save. Right? Then we have done that. It says note, changes will cause the home router to reset. Close the web browser and click fast forward. Return to home PC and click IP configuration. Check if the IP is reassigned. Okay. So we close this and then we go back to home router. Okay, first of all, they say we should check if the IP is reassigned. How do we check if the IP is reassigned? Come here. Sorry. Command prompt here. And we do IP config. And then, okay, so we should do fast forward. Okay. IP config. And then this is the IP that we get, the IP of the router. So as the default gateway, can you see? Our default gateway, this is the router. So I will come to my browser here and we will enter that IP address. Okay. So we'll enter 192.168.0.1. Okay. Username admin. Password. Remember, we copied it. We just paste it. And then it will grant us access. Now, it says part 2. I finished part 1. Part 2 says configure the wireless router network security. So what do we do? Step 1, configure and broadcast the home net SSID, right? So how do we do that? It says click the wireless tab. Okay, click the wireless tab, which is here. And then, what did they say? And then for each of the 3 networks, click enabled for the SSIDs. This is the first network, we'll click enable here. This is the second network, we'll click enable here. And then the third network will click enable. Okay. So what else did they say we should do? Right. So for each of the three networks, change the SSID from default to home net. This is default, so we'll change it to home net. Okay. This one will be home net. This one will be home net. Okay. Then I will save my settings. Right? Because they say C here says save your settings. Step 2, configure security for the home net wireless networks. How do we do that? From wireless tab, click wireless security. Right? So let's go back here. Wireless tab, see wireless security here. Right? So you see all of it is disabled. So B, for each of the three networks, configure the following. Security mode, WPA2 personal, and then encryption AES. WPA2 personal, encryption AES. Let's see. And then there's a password here. Cisco Rocks. We create a password. Cisco Rocks. And this one, WPA2 personal, Cisco Rocks. Then we do likewise for this one. We type the password, Cisco Rocks. Then we come back here and we save our work. All right, so we save our work. Part 3. Part 3 says configure security for the guest wireless network. Okay, guest wireless network. So from the wireless tab, click guest network. So let's come back here. From the wireless tab, see guest network here. Okay. And then B says for each of the three networks, click enable guest profile and then configure the following. So SSID is going to be guest net. Okay. Broadcast SSID. Security mode, WPA2 personal. Password will be guest pass. Okay. So we're done for this first one. Do for the second one. It's going to be guest net. Broadcast SSID. Okay, this one personal. Password will be guest pass. Third one, guest net. Class SSID. Personal. And then guest pass. Then we save our work. So we have done this. We go to now part 3. Part 3 now is we want to configure wireless clients. We have configured the wireless router now, the access points, wireless router, we have configured it. So we need to configure the clients that are going to now connect to that wireless. access points. Okay, so what do we do? Step one, configure wireless connectivity for laptops. So where the laptops, click laptop, home laptop one located in the living room, and click desktop and go to where's the living room? I guess this is the living room. This is laptop one, okay. So click laptop one, and then we should go to desktop, and then we go to PC wireless. This is here. Then it says click the connect tab. This is the connect tab. And then it says click the first entry for HomeNet and click connect. Okay, this is HomeNet, the first entry, and then click connect. Okay. Then it says security is already set to this. So enter Cisco rocks for the pre-shared key. So Cisco rocks. And then connect. Okay. Then click link information tab. You should see the message you have successfully connected to the access point. Okay, you have successfully connected to the access point. So this one is correct. Okay. F. Okay, no. Check the config. Okay. F says, let's see what F is saying. F is saying close the PC wireless windows and click IP configuration. If the laptop still has an address from 169 network, toggle between the DHCP and static until it receives an IP address from 192.168. Okay, so we're supposed to come here and check IP configuration. So you see it's showing IP configuration static. We're supposed to put it at DHCP so that it will request IP and get, so you see it has gotten the IP now. Okay, it has gotten the IP now. So good. So we can close this. Okay. Then it says repeat the steps for laptop 2 in the home office, but use the first entry for guests network. Okay. So laptop 2. Where's laptop 2? Yes, this is laptop 2. Okay. Right. Come to desktop. PC wireless. And then it says connect. And then they say, what was the instruction? Repeat the process for home network in the, but use the first entry for guest net. So this is the guest net. Then connect, and the password for guest nets is guest pass. Connect. So we're supposed to check link information. You have successfully connected. Okay. Then we are to check IP configuration. Static, we put DHCP and wait. We should be able to see our IP populate here if everything goes well. Correct. So it has gotten an IP from the DHCP server. Okay. Right. Then that's G. We have done for G. Okay. Then step 2, configure the wireless connectivity for the IoT devices. Okay. IoT are Internet of Things devices, and this is like a smart home. And in a smart home, you may have curtains, you may have fan, you may have doors automated, you may have other devices that are automated. So we're supposed to do that configuration. So it says configure the wireless connectivity for the IoT devices. So in the home office, on top of the shelf of the bookcase, click the home webcam. All right, so this is the home webcam, I guess so. The home webcam, this is on top of the bookshelves. Let me see. In the home office, on top of the shelf of the bookcase. Guess, or is this? This is home siren. This is home siren. Let me follow the instruction in the home office. On the top shelf of the bookcase. Is this the bookcase? Yes, so. Is it this one? Or this is the living room, right? Or is this the home office now? The top shelf of the bookcase. Aha, look at it. This is the webcam. All right, so we click the webcam. Very good. It says click config and then wireless. This is config and then wireless. Okay. Wireless. Enter the home net for the SSID. As the SSID, so enter home net. Okay. And then it says, so we want to connect the webcam now to the network. That's what we want to do. And then it says preferred key is WPA2. Is this? And then password says Cisco Rocks, right? Where is it? Cisco Rocks. Under IP configuration, okay, it says under IP configuration, click DHCP. Okay, so click DHCP here. And then verify the device receives IP address. So good. No, it's not receiving IP address. This IP address is not the same as this IP address. Okay. So let's try again. So it has gotten the right IP address. You see the IP address has gotten 192.168.0.network. Okay, that's good. So now that we have done this, and they say repeat this step for both the home siren located in the living room, both the bookcase and the home doors. So we'll do home siren and the home doors. So I guess this is the home siren. Okay. What are we supposed to do? Config, go to wireless, SSID, we'll put the one for the home net, right? And then password, we'll say Cisco Rocks. Then this, go for DHCP. Let's see if we can toggle it. Right. Good. So we go for the home doors. Where is the home door? Is this the home door? We need to find out. Okay, I guess this is a door. Correct. Home doors. Okay. Home doors. I come to wireless here. And then say home net passphrase. Let's go rocks. Then see. All right. So now we have done. Let's check our score. All right. See our score, completion score 100%. We can check our result if we so wish. You click here and you come here and see items. Oh, we missed something one here. IP address. Where? On the home door. IP address of the home door is incorrect. Okay. It's correct. Are we supposed to have assigned? Check what it scored us 100. Let me see. 38. Okay, 37 over 38. So it's saying we completed it at 100. Okay. So I think we have done justice to it. Let me check the home doors. Okay. Yeah, I think we're correct. We don't have a problem. All right, so thank you very much. I think this is where we will draw the curtain for today's class, except probably if you have a question or something like that you will want us to address, then we'll look at it together. Any question? Any question? All right. So in the absence of any question, I want to thank you all for participating.
Mr. Sati, I have a question, sir.
All right, go ahead.
Yeah, my question is, I was trying to, I don't know if the packet tracer activity has been activated. I was trying to launch it. I was trying to launch it after downloading the packet tracer activity you sent to us via the cloud. launching it, I was asked to log in to my NetaCard account or to Skill to All. So which I log in with my NetaCard account. But after logging in, it wasn't bringing the interface of the packet tracer activity. Rather, it was just showing me the interface of my NetaCard, this thing, like say the interface of the NetaCard instead of taking me to the packet tracer activity. So I dropped a voice note for you. I know you are very busy. You didn't check it out. Oh,
Sorry.
I said, let me also ask now because I don't really know how to go about that.
Oh, so sorry. I didn't get your voice note. Okay. So what we will do, let me open my own, let me close the packet tracer activity I have here. Which of the packet tracer activities were you trying to run? Let me share my screen back. Which packet tracer activity were you trying to run? Okay, so you see, this is the packet tracer activities that I sent to you. This is the one we just did today. Where is it? Wireless. This is the one we just did today. Okay. And what it will do if you log in once, it will hold your credentials for like 3 months unless you don't want it. So now I've already logged in. If I double click this, it will not ask me to log in. Okay. So if you double click, for instance, and you have already installed the packet tracer on your system, you should not have a problem. So let me show my entire screen. Okay. So you see, so I double click, so it's going to be loading. Okay, so you see, it has loaded. I don't know which one you were having challenge, and I don't know why yours has not loaded. But on a normal day, it should be able to load it straight away for you. Okay.
Okay, I'll try again. If I encounter any issues, I'll get back to you, sir.
Please do. Please do. Please.
Thank you, sir.
All right. So the assignment I'm giving you now, our next class is going to be on Sunday by 8 p.m. So you see, you have tomorrow, Friday, you have Saturday, you have Sunday, you have Monday. Okay, you have tomorrow, Friday, and you have Saturday. Then we will meet on Sunday. So the assignment I'm giving you now is to go and study Module 3 and Module 4. Okay, and then also do the packet tracer activities for Module 3 and Module 4. There are about 1, 2, 3, 4, 5, 6, 7, 8 packet tracer activities. All right. Or just do, okay, that would be a bit too much for you guys. So if you just do as much as you can do before we meet. So Module 3 is very important, and Module 4, especially when it comes to the configuration. So I encourage you to study Module 3 and Module 4 of the materials. Do your quizzes, do your exams, do your checkpoint exam. And then once we meet, we will combine, see what we can do. It's 10:04. Thank you very much. I will be uploading the recording for those that probably could not make it. All right, feel free to play it over and over and send to others. Good night.